All right, thank you for your patience. Good morning, everyone. You know, as Devin was talking, you know, in part of his presentation near the end, he started talking about some of the sustainability issues and the water-energy nexus. As most people here know, the energy used for water transport and treatment, including wastewater treatment, represents about 20% of the energy use in the state. Very, very significant. And so it's an important element, and when we get into wastewater treatment, in fact, the treatment of wastewater requires more energy than the treatment of water, typically, unless you're doing ocean desal. But if you're doing just standard treatment, wastewater treatment does require a significant amount of energy. But as we've gone over history, certainly over the last several decades, there's been a paradigm shift, certainly within the wastewater industry, from how do we dispose to how do we sustainably reuse, beneficially reuse, what's produced in the wastewater treatment process. In fact, I went out and I looked at a couple of mission statements, my agencies included, and there's still that word that the mission is to treat and dispose of wastewater. Well, I'm going to change ours, go to our board, and we'll change that because the objective, our mission is really to beneficially reuse resources. So this is resource management. At Inland Empire Utilities Agency, we're upstream from Orange County. In fact, our wastewater that we don't recycle does flow down the Santa Ana River into Orange County, and it's part of the water supply for Orange County.
Thank you.
So the treatment, you're welcome. and Orange County likes to see that water come down the river as long as it's clean.
Yes.
And doesn't have too much salt in it. But as we look at how do we beneficially use these, Halloween was a couple of days ago, and I want you all to think about the prank, Halloween prank. How many of you here have done this prank after I tell you what it is? So you put something disgusting in a paper bag, put it on your neighbor's porch, and you light it on fire. How many of you guys have done that? Come on. All right, there's a couple. And the reason I say that is because our sludge. What do we do? What did we historically do with our sludge? Well, once we developed and the area became very populated, we didn't have any land to go put it on in our own neighborhood. So we went to our neighbor's yard and we put it in there, on their farms. And we did sludge disposal. Well, guess what? Kern County, Riverside County, other counties saying, hey, don't play that Halloween trick on us anymore. We're tired of that. So we need to look at other more sustainable ways to deal with our biosolids, which is part of the panel's discussion today. So with that, I'll get right to it and introduce our first panelist, Paul Cook, who is General Manager of the Irvine Ranch Water District. And Paul is a registered civil engineer. I've known Paul for quite a long time. I'll give him a hard time. 22 years plus experience in water, wastewater. Been general manager since last year, about a year. Congratulations, anniversary. Happy anniversary.
Thank you.
Good. And previously was engineering manager for Central and West Basin municipal water districts.
That's enough.
Yeah, member agency of the NWRI, and with that, I'll introduce Paul Cook. Thank you.
Thanks, Tom. Thanks, Tom. Let's see if I can get this going here. Great. So I'm going to talk today about sort of a practical solution, and I think we'd start at the level that we're at. We're at the level at which we actually have to get stuff done. So I think from that level, we can work into some of the more cutting-edge things coming up in the future. So we're going to really focus on what we're doing at Irvine Ranch Water District. Quick presentation overview. I'll talk about the agency, but then get right into the project, our Biosolids and energy recovery project, as we call it. The objectives, some of the alternatives we considered, then get into a description of the project. I'll talk specifically about odor control, since that was a big consideration for us, as well as the utilization of the biogas. And then the end product we're going to be having from this process is pellets, biosolid pellets, and how we're going to reuse those. Quick shot on the schedule, and then hopefully we have some time to talk about some future research opportunities we have on the project. So Irvine Ranch Water District, we are a retail agency, a public agency with 5 publicly elected board members. We serve about 340,000 residents. We have a large kind of a work area of Irvine that surprisingly it swells that population up to about 500,000 folks, 100,000 service connections approximately. So You can see we're one of those 300 agencies that Devin referred to, but we serve about 20% of the area of Orange County. And within our area, it's not just Irvine, it's also 5 other cities and some unincorporated area of Orange County. So just to give you context of where we sit relative to Orange County. The agency itself, we have on the potable water side, we do potable water. We serve water through, we have primarily a well system. We have met water as a source of supply, but we have 3 treatment plants, 25 wells, about 1,500 miles of pipes. On the wastewater side, we have about 1,000 miles of sewage collection pipes. And I guess I'm one step ahead of you, Tom. I did take the wastewater part, I put the treatment part into the recycled water genre. So we view it exactly the same way as our good folks in the Inland Empire do, which is it is a resource to be reused. We've been recycling, as many of you know, for many, many years. We have 2 water recycling facilities, the 28 million gallon per day facility and a 5.5 million gallon per day facility. I'll talk primarily about the 28 million gallon per day facility, which we call the Michelson Water Recycling Plant. We also do urban runoff treatment, low flow treatment through a series of ponds. That's probably a whole other couple of presentations, but that's another part of our core function at IRWD. So getting into the project objectives for the Biosolids project, quick look back on our history of solids handling. In the 60s, 70s, and 80s, we did, like most treatment plants, we had your typical activated sludge plant, and then we dewatered our solids and we found a place to put them. And back in those days, obviously, regulations were a lot more lax, and we were able to do that much easier. In 1988, we began piping our solids to the Orange County Sanitation District. We had the means and the infrastructure to do that relatively easily. We also had a pretty good pricing structure from the Sanitation District. They basically charged us on a per gallon basis, similar to what they would charge us for sewage. Some of our sewage from our service area would flow to the Sanitation District just naturally, so we had this arrangement. But we were actually getting a pretty good deal if you think about what we were sending down the pipe as sewage, what we were sending down the pipe as dewatered solids, a lot more strength in that solids, but we were getting a pretty good deal on that. In 2005, Sanitation District said, "Hey, you're getting a pretty good deal on that." And they also wanted to begin expanding their facilities and realized that as we continue to expand in our service area, that they need to build new facilities. So before they launched off on their next expansion, we said, "Time out. Let us take a look and see if as an alternative, we could treat our own solids at our site." So a little spoiler alert. Yeah, we did start to think about doing that, and that's why I'm talking to you today, because we're in fact undertaking that now. So we're going to get back into the biosolids handling business. The objectives of the project were really to obviously institute improvements that would allow us to efficiently and sustainably use the renewable resource that will result from this process. Definitely want to use the beneficial reuse on the solids, but also on the biogas. We did see that as a resource as well, with the alternative being flaring or some other things that weren't quite as beneficial, obviously. We wanted control. I think anytime you're a utility, there's a high expectation on the part of your customers that you have some degree of control. Sanitation District was great to work with over the years, but they have their own set of challenges on a grander scale. We do anticipate working with them forever because of how we're connected to them, but we felt that control over our own destiny in terms of solids is a much better place to be. We certainly wanted to minimize the impacts for the environmental impacts, and then construct a solids facility and energy recovery facility that would address our needs going forward through our ultimate build-out phase. We looked at a number of different alternatives, but let me lay out a roadmap here and kind of construct the whole picture, and then we'll get into some more specific alternatives. We have primary sludge and waste activated sludge, and we send that to Orange County Sanitation District. That's our traditional model. And then we considered, well, we could do the thickening and anaerobic digestion ourselves. We could stop there, and then again continue sending those solids to the Sanitation District in a different form. We could then layer on perhaps a raw sludge dewatering process and use composting, incineration, or e-fuel conversion. Or we could get right into treating the solids into what's referred to as Class B, which is a EPA designation of a quality of solids that allows you to dispose of them in a certain way. The options are listed down there: composting, landfill use, land application, and different things like that, or sending them off to somebody else to dry and use a different way. Or go to Class A. This was another consideration that we that we took into account. And we looked at Class A being a much higher quality, as the name would imply, local fertilizer, working with a partner to dispose of the fertilizer product at the end of the day. You could still incinerate it, and you can also and use it for e-fuel. E-fuel is a fancy word for it's not coal, it's not natural gas or some other. It's a e-fuel, so it's kind of a beneficial reuse. It's not the best, but it's a fuel source for things like cement kilns and other folks who burn locally. Not locally as in the South Coast Air Quality Management District, but locally, it's like just outside the South Coast Air Quality Management District. Define local in that context. And then, again, looking at the gas as far as all the alternatives for this project, what would we do with the gas? Fuel cells, internal combustion engines, microturbines, dry air fuel, and energy, or sending it to an energy partner. That's kind of the universe of all of the different alternatives we had available to us for the problems we needed to address under this project. We really developed 6 different alternatives, and I won't go through them all, but I did highlight in bold, if you can tell, number 2 and number 6. The baseline was sending it to the sand district, and we realized we probably can do better than that. Digested solids were a little bit better on that arrangement because the digestion would allow us to have use of that biogas that came off that process. So it came down to really an analysis between number 2 and whether we wanted to go all the way with alternative number 6, which is the pelletization, and really no residuals being sent to Orange County Sanitation District. So going through the different alternatives, on the capital side or the cost side rather, we had capital costs and operating costs, which we tried to kind of bring into a uniform across the board comparison that we could then do a payback analysis, whether we would just kind of keep going along with the sanitation district on what would essentially be kind of a leased arrangement with their facilities that we would then be paying every year. So we knew we had something to compare against. And then if we were in fact to build our own facilities, what would that payback look like? So here's the cost, and you can see, we didn't show it before 2005 when it was relatively inexpensive, but you can see the costs increasing over time. And this was a study that the Corollo had done in partnership, on behalf of Irvine Ranch Water District and the Sanitation District. We have a good enough working relationship with our partners at the Sanitation District. We felt that having one consultant preparing this as kind of a neutral third party to tell us what these costs would be, and we were both very satisfied with the results in terms of the quality of their work product. But what ended up happening is we could look out into the future, and as we look way out in the future, it does start to get uncertain after 2012, and so we had higher escalations and lower escalations. But regardless, these costs will continue to go up in the future as far as cost to us. So we looked at the high and the low of the alternatives, where those lines started to diverge a little bit, and you can see the cumulative costs, and I believe these are in 2012 dollars or 2010 dollars at the time. So $702 million, $632 million, and then those were for alternative 1 with the sanitation district. And then you can see alternative 6, which was the pelletization energy reuse version, $414 million as cumulative costs, with a payback year in 2023. So again, we had some pretty good data, and we knew we would be looking at some kind of a project. Just what technology should we deploy to make this work to our advantage? So if you're probably all studying those different numbers, and you're noticing that there's actually one cheaper than the 414. There's some more expensive as well. And I will definitely touch on why we chose a project that wasn't ultimately the lowest cumulative cost, strictly on a cost basis. Non-economic evaluation criteria. This is how we get there. What we looked at is, once we got into the realm of, okay, now we know what the costs are, ballpark relative to each other. Well, more than ballpark, we spent a fair amount of time on them. But we also wanted to consider the non-economic evaluation criteria. So we came up with some non-economic criteria that was important to the agency. First being autonomy. I touched on a little bit already about autonomy and our ability to be independent in our biosolids management decision making. Implementability. This really gets down to the ability to put in whatever we were going to do in terms of getting permits. A lot of times we think about great new technologies, but the regulatory agencies are about 10 years behind us. So it doesn't do much good to construct a facility when you can't get the permits for it. So we considered implementability as a consideration for a non-economic criteria. Community impact, certainly our treatment plant, which I'll show you a picture of the site in a minute here, but we're right in the middle of Irvine, and there are considerations for noise, traffic, odors, and other things. Environmental stewardship as a non-economic criteria, we did want to end up with a product that would be the right thing to do environmentally. Technology, not only implementability on the technology, but just flat-out proven technology and reliable technology, very important to us. And then the long-term viability, staying one step ahead of the regulations in terms of our final product. Going through the exercise was actually quite interesting on the non-economic criteria because it was a little bit a lot subjective in times, but we felt we came up with a pretty interesting methodology by which we were able to rank the different non-economic criterion on a kind of a 1 through 5 type scale. And you can see that the baseline, there's some definite benefits to the baseline alternative number 1, but there was also some definite benefits to number 6. Excuse me. So what we did was we looked at what was really driving number 1. It was easy to implement. You just call sanitation district and says, here comes some more, and write them a check. But we sort of didn't have the autonomy which we were looking for. But if you look at alternative 6, it was still relatively easy to implement, not quite as easy, but we're not afraid to take on new projects and new technology at IRWD. So we felt very comfortable with the project we came up with. But we also had a substantial amount more autonomy, so we scored better in that category. So then what we did is we took the cost, the economic criteria, and the non-economic criteria and layered them onto each other. And you kind of stand back, and the answer does sort of fall out for you. The line is an indication of the economics, which is the far right side on the y-axis. Those are the dollars, and then the bars are the non-economic. So when you see a low-cost project with a high non-economic outcome on the evaluation process, you say there's your winner. And our winner in this case was the alternative number 6. And that's how we came up with the selection process for going forward, benefits and life cycle costs combined. So the project we selected, it does have anaerobic digestion of biosolids. It will produce electricity. It will produce a pelletized product, as shown in the person who's holding that right there. And we hope to have this project on, well, we started the design back in 2009, hope to have the project online by 2016. That's a quick overview. The benefits of the project, greenhouse gas effects are lower by using the pellets locally. We do have a reduction of the truckloads of product finally end up leaving our plant. We're not shipping water out of our facility, we're shipping almost all solids out of our facility when we end up with the final product, so that's a good thing. It does beneficially reuse the product as either fertilizer or e-fuel. Greater environmental stewardship, so we check that box. It does result in a lower overall economic cost to the community. If you remember back on the chart, the 700 million cumulative cost versus the 414, so it is still beneficial. And it really positions, this is an important thing for IRWD relative to our community. There's a high expectation of our customers to be positioned as a proponent of sustainability, and the city of Irvine shares that ethic also, and they share it so much we actually called them out on it. We had a meeting, I believe it was a day or two ago, and we had met right after lunch with the mayor and the mayor pro tem as part of our normal meetings, and we actually had a sample of the pellets, and it was right after lunch, and they actually smelled it, and so they did okay. They did okay with that. So describing the project, we'll have biosolids dewatering, and then the gas, and then the odor systems handling. Again, we wouldn't be exporting any solids to the sanitation district, and that we would also, another element of the project is that second treatment plant, the 5.5 MGD facility in the next town to the south of us, it's probably a 15-minute or so truck drive. We would actually be able to take the solids that accumulate in that particular plant. It's a facultative pond process, so a little different than a waste-activated sludge, but it does have solids. Those would be trucked up, dewatered centrifuges, and then trucked up to our dryer facilities. So we had that ability. So from both of our plants, we could result in a pelletized product. And then the other element of the project is that it would be constructed on land that was already disturbed. So we're not taking any habitat or going into any new areas. We already have the land within our Michelson water recycling plant. So here's that graphic I wanted to show you very quickly. It's a little bit grayed out, but the dashed lines is the overall property owned by Irvine Ranch Water District on the larger kind of rectangular shape. The smaller rectangle is the Michelson plant facility, and the red hashed area is where we're going to be constructing our biosolids facilities. And you can get a feel for the homes and the businesses, and there's the airport. Some of you might have flown into John Wayne Airport. It's just to the north of us, west of us there. So it's a relatively urban setting. But you can also see that there's a fairly large buffer around that plant itself, which is a large wetlands area and some marsh areas for hiking and things like that. It's a nice buffer for us. So it's pretty well positioned in spite of what we're doing there. A little more close-up view of our facility. A lot of this has changed. We are constructing about $100 million expansion to our facility right now to take us from 18 or 19 MGD up to 28 MGD. So a lot of this is disturbed and looks a lot better than this slide shows. But you can see our biosolids facilities will be just to the, I guess, west of the plant, but still within the plant. So here's the schematic for what we came up with. I'll talk slowly so you can drink it all in and understand it, but it's pretty straightforward. Once you get through the clarifiers and then the thickening centrifuges, it goes into your typical digestion processes, an acid phase digestion that does generate the gas. But what happens after the digestion is that it goes into the centrifuge. At that point, we have the ability, that would be considered Class B sludge. So we could theoretically, if there was an issue or downtime on the dryer, we could at that point very easily ship that product off to wherever our disposal options would be at that point. And unfortunately, with Class B, you kind of have to use the term disposal because the way the regulations are set up, it's not as easy to handle that product and use it beneficially. But on Class A, certainly much more beneficial reuse opportunities. We go through the dryer, and unfortunately the dryer is a little tiny purple box there, but it's pretty much driving the whole project. It's a very substantial portion of the project, and it really is the heart of what we're trying to accomplish in forming the pellets. After the pellets get formed, then they would be loaded out to trucks and hopefully used on HOA, homeowner associations, city property is what we proposed to them yesterday, and then other folks, even our own property. And then the gas goes up and it gets cleaned and gets run through microturbines. We're going to use egg-shaped digesters. I won't go into the benefits too much of egg-shaped digesters. They've been around for about 20 years, but we feel this was the most beneficial form of digestion that we could come up with, going through the different maintainability, operability. And who doesn't like, I like the last bullet, clean dome appearance. Who doesn't like the clean dome appearance? I really found that beneficial. A quick view, a side view of the main thing here. You can see the circulation process. Again, you're probably all familiar with that. But it's remarkable how deep these things end up going, and it's still about 65 feet tall. So that was a consideration. We like to reference the Mesa, Arizona. It's not going to be designed exactly like that with the geodesic-looking connections, but all of our pipes will be contained also. And Mesa was a great project for us to compare to because it's the same dryer, odor control issues and things like that. So we had kind of a guideline to go by. Again, here's the plant, the biosolids portion of the plant with the dryer building, the main part of the main boxy area, and then digesters off to the side. I'll go quickly through these pictures here. I have a little video at the end I can show you, kind of a fly-through in the building. I'd rather do that than spend a lot of time on these. Get a feel for how large these facilities are going to be. The building itself is about 70 feet tall. Some inside views. Dryers, upper view. So the odor control system, the components of the odor control system, really it's the odors, the H2S that are coming out of the different, whether it's the bagging area, the load-out area, the load-in area. There's lots of areas that are going to have some odors associated with it. The regenerative thermal oxidizer for off-gassing of the dryer is another component. And then the biogas conditioning prior to the microturbines. But basically, a very robust system that will keep the staffing or the people areas, as we call them, in positive air pressure, and then the equipment areas will be in negative air pressure. And a quick cutaway, you can see the sources of the odors of the different areas, a couple of blowers and a very redundant system, and even triple redundant on how the gas would come in and for H2S removal, not once, not twice, but 3 times to make sure that there's no possibility for breakthrough. And there is emergency power backup to that system as well in case we did lose power there. So here's some photos of the odor control systems again at Mesa. On biogas utilization, we really considered 3 different cases here. One was basically using the gas primarily for the dryer and for the boilers. The boilers would then provide some heat back to the digesters to promote that process. It doesn't get terribly cold in Irvine, so it wasn't a big demand on that boiler. We would result in some extra gas that would eventually just be flared off. So we considered that as kind of a base case scenario, low cost. Then we looked at the fuel cell alternative, and at first we were quite excited about this, but what we came into considering with the fuel cell was a similar sort of non-economic evaluation with reliability was a big driver with the fuel cells. I know fuel cells have been implemented and implemented very successfully, but we were frankly on the tail end of the rebate programs that have been very popular and beneficial to folks who have been. I believe Inland Empire has fuel cells, right, Tom? Yes, so they, they are in place and working. But we felt for our process, the way to go was going to be microturbines, proven technology, very reliable, and again works economically as well as in the non-economic criteria. We'd still use some natural gas to supplement the dryer as well as the biogas. Here's a quick idea of how much electrical power we need, kind of skirting from left to right is about 6.9, currently at 23 MGD, but in probably the 10-year time frame, 28 MGD, we'd be up to 8.5 megawatt demands. And that's about 18% of our demands could be met in about 10 years. And we're also looking to bring in other sources of fuel, if you will, for this gas generation project. And again, there's a little graphic showing how this comes together. Quick picture of the biogas facilities, microturbines. Pellet marketing. We have done a study to look out and with the goal of maximizing our use of the pellets locally in a very beneficial way. So we have areas identified. Large square, dark green is the Great Park. You might have heard of the Orange County Great Park. Substantial commitment by the area, the region, to have a lot of parkland over there. Hopefully we can use them as a customer. And then the number of other sites have been identified. But again, we have begun talk with the cities, but we're still a few years away from actually having finished product. But this will certainly be one of our focuses in the future going forward. On the schedule, we just last Monday, our board certified our EIR. The City of Irvine will be having a hearing next week on the conditional use, or 2 weeks actually, on the conditional use permit required for that nice tall building and those tall digesters. And then we expect construction to take place over about a 3-year period. We are on we are out to bid right now, and then hopefully we'll have that start up by 2016 for early part of 2016 for the Class B and then the Class A. Our estimated construction cost for this project, just on the construction side alone, is about $150 million. So again, we're just finishing up our largest capital improvement project in the history of the agency, and we're undertaking the next one on the heels of it. Research opportunities, a couple terms you might recognize. Open cell, it's a cell lysis technology, or if I need to drop it down a level, it's a cell explosion technology that bursts the cells in a way that releases the carbonaceous material, and it actually results in less solids and a higher production of gas. So it's something that we considered, but we thought we can implement that at a later time. Again, we were first focused on getting a project implemented, constructed, that our staff could be very comfortable with and operate reliably. Austera is a phosphorus removal technology that can concentrate phosphorus. We looked very hard at Austera, realized that for the amount of phosphorus in our sewage, it probably isn't there yet, but as phosphorus costs increase in the future, there could be an opportunity for a future implementation of an Austera system. Food waste is an interesting one, probably the most exciting, if I can say that, of the three. Food waste is a fancy word for taking the direct food in the trash from a cafeteria, say at a university or restaurants in the area, and getting it separated out, the non-carbonaceous material, but getting it into a slurry form, having that brought in, and then putting that right into our system that will actually promote, it'll serve as a fuel source for our digesters, generate more gas. We are going to have a fats, oils, and grease station, or a fog station. That will be, again, a really great way for us to get more gas coming out of our system at the end. So this is a shameless plug for Dr. McCarty's students. This apparently a number of our project team went to Stanford, so this way, if there's anything wrong with this project, we can always go back to Dr. McCarty, who's coming up next. We'll blame it on him. But I did want to take an opportunity to thank my project team. Well, I guess first and foremost, my board for having a few of them are here in the audience, the courage and the confidence in IRWD staff to take on a project like this. But Steve Malloy is here. Steve's our project manager. And Steve's, while he was running our largest capital project, he was beginning the design of this, the second, or I guess the next largest. And then Jim Clark in the front row here. He had the courage to sit in the front row, thanks, or almost the front row, from Black & Veatch. Did a fantastic, fantastic job, and we are moving forward. So I will stop there, and that wasn't too bad, was it, Tim? Good. Thank you very much.